Kinematics graph basically tells you about the motion of an object. So I'm going to assume you remember what displacement, velocity, and acceleration are. And the relationship between the graphs is that you take the gradient of the displacement time graph to get velocity time graph, and you take the gradient of the velocity time graph to get the acceleration time graph. And to convert back to the previous graph, you just take the area under the graph. And an important thing to note is that when you take the area, you have to add what is above the x-axis and subtract what is below. So for example, we have a simple displacement time graph here. Let's just say the area of this is A and the area of this is B. So the displacement will be A minus B because A is above the x-axis and B is below. Okay, so we can start off with some basic cases of turning displacement time graphs into velocity time graphs. So the first one, we have a constant displacement. So when time increases, your displacement doesn't change. So this means that you're not moving because your position or displacement stays the same. So this means that your velocity is 0. So we can just draw. Okay, for the next one, your displacement is increasing when your time increases. And as you can tell, the gradient of this line is constant. So we can draw a horizontal line at this part of the graph because the gradient is positive, so your velocity should be positive. For the next graph, you can also tell that the change in displacement is constant because it is a straight line, and as it is going downwards, you can tell that this change is a negative one. So we can also, again, draw a horizontal line, but this time below the x-axis because it is negative. So now we can move on to some more complex cases, which is when the displacement time graph is exponential. And this might look a bit scary at first, but it's okay. It'll all make sense in the end. There are two things you have to take into consideration. So first, if the displacement is positive or negative. Like in the first two graphs, you can tell that it's going in the positive direction, while on the bottom two graphs, it's going in the negative direction because it is tending towards 0 displacement. And the next thing you have to take into consideration is if the graph is increasing or decreasing at an increasing or decreasing rate. So that might sound a bit confusing, but I will illustrate it for you right now. So let's take the first graph, the one on the most top. If you draw its gradient across points along the graph, you can tell that its gradient is increasing. And how do you know it's increasing? Because the slope is getting steeper. Or, okay, slope is another way to say gradient. So its gradient is increasing. So if I try to graph this, well, let me write this down first. You can tell that the velocity is increasing because the slope gets steeper. So when I try drawing the VT graph, it'll look like this. And as you can see, firstly, the graph is positive, and secondly, that it is increasing because the gradient of the displacement time graphs keeps increasing. So now let's try the second one. If you keep drawing the gradient along the graph, you can tell that decreases because it gets less steep. So what does this tell you about the velocity? Well, that decreases because the gradient is getting less and less steep. So if we try drawing this graph, it'll look like this. So here, the direction is positive and it is decreasing. Let's move on to the next example. So here we can tell that the direction is negative because it's going towards displacement equals 0. And if we draw the gradient of the graph, you can tell that it decreases. Yes, it is getting steeper, but you have to note that it is in the negative direction. So it is a larger negative number when time increases. So that's why the velocity decreases. So how will the graph look like? So firstly, as it is in the negative direction, we want to draw it below the x-axis of this graph. And second, as the velocity is decreasing, it'll look something like this. Okay, for the next one, you can tell by drawing the gradient that it gets less and less steep, so your velocity is increasing, and your direction is negative. So how will this graph look like? Again, as it is in the negative direction, you have to draw it below the x-axis, and it will look something like this. You might be wondering, how am I supposed to turn these exponential velocity time graphs into displacement time graphs? For this, all you have to do is you look at the initial and final values of v. So for the first two graphs, the initial velocity is at 0 and it slowly increases. The graph should look something like this, because the initial gradient of the displacement time graph should be smaller than the gradient at the end. And for the second two, you can tell that the initial gradient of the displacement time graph should be larger than what it is at the end, because these two graphs decrease. So it will look something like this. So you might be wondering, what happens if the graph is actually under the x-axis, so it will look like this? Then how would the velocity time graph look like? As you can tell by the gradient, the velocity is increasing and the direction, you're still going in a negative direction. So then your graph will still look the same. So whether it's above or below the x-axis, it shouldn't matter. What I'm basically saying is that the motion for these two are the same. It's just that from your reference point, one of them is done in the positive direction, which is this one, and the other one is done in the negative direction, which is this one. So that is why the displacement time graph looks different, but the velocity time graph remains the same. Okay, now we can move on to velocity time graphs to acceleration time graphs. So it's kind of similar to the first case, where no change in velocity means that your acceleration stays at 0, and constant change in velocity means that your acceleration is positive and the change is constant, so it's a straight line. The next one is similar to the first one, it's just negative because the constant change is negative. So when you want to try to draw a velocity time graph into an acceleration time graph, there are two things you have to take note of. One is the change in velocity, or the overall gradient. So if you take the gradient of every single point, is it negative or positive? And this will determine whether you draw your acceleration time graph above the x-axis or below the x-axis. So for instance, in the first case, we have all these gradients. As you can tell, they are positive. So we draw the graph in this region, the positive region, for both of these cases. So for the first case, you can tell that the gradient is getting larger and larger as it's getting more steep. So the acceleration time graph will look like this. For the second case, you can tell that yes, the gradient is positive, but it is getting smaller and smaller. So again, it's still above the x-axis because it's positive, but we make it towards the negative direction. For the next two cases, the gradient of these graphs is negative, but you can kind of tell because it's decreasing. So we draw the acceleration time graph in the negative area. You can tell that the velocity is decreasing because it is getting more and more negative. So the graph will look like this. And for this case, it is getting more and more positive. So it will look like this. And if you're wondering if the velocity time graph looks like this, the acceleration time graph will still look the same. And an interesting thing to note is that when your velocity is almost constant, that means you have no acceleration, which we know. And you can see this in the graphs. So from the second and fourth graph, you can kind of tell that the velocities are almost becoming constant because the velocities are almost becoming a horizontal line. In the acceleration time graph, you can see that both of their accelerations tend to 0.